it's really hard to talk after Sebastian because he talks every day. So for me, it's just once in a while. So I am Andrea. I work as a senior engineer as a Just Eat Takeaway, and my adventure with serverless started when I worked for a consultancy agency. And we were doing a mobile app for a UK government agency. And I had the opportunity to do the full app in Swift and serverless. At that time, serverless was just with other languages, so I had to choose one of the company choice. But things have changed, and now since that day, I think 5 years have passed. And we have Swift on serverless, as Sebastian introduced to you. And I will show you how we can do a full mobile app using serverless in Swift. So we will have the mobile app plus the backend in Swift with the REST API. During my talk, I will show a little bit of a different approach from the one that Sebastian introduced us, which is rather than knowing how to describe the deployment, I will create a full project and then you can change it. Let's start with a quick overview of what we will do today. So I will show first the demo app so you can understand what we are talking about. And then I will show you a little bit the architecture of the serverless and the code structure, and then how we can generate the code, because the package I create allows you to create the code, and also the deployment, which is similar to what Sebastian showed you before, but with a different tool, which is called serverless. And then I'll go back to some question that we always have: why we use serverless, why we should use Swift for serverless, why we should use my tool that is called Breeze. So let's start with the full stack Swift app. The app is written in Swift UI and use Apple sign-in to authenticate the user with the API, and implement a create, read, update, delete interface. Usually people use the classical task to-do list app, which for me was too simple, so I wanted to do something a little bit more difficult, which is an app that manages different forms, and they have a more complicated structure in the code. So let me see if I can show you the app. So I will show you the app live. So first of all, I sign in with Apple. So I'm in. At the moment, there is nothing on my backend, so I will enter a form. And here we have some questions just to start. What's the main benefit of serverless computing? Cost saving, performance, scalability, infrastructure as a code. If you start a new project, would you use serverless on AWS? I would say yes. Would you change your favorite coding language to start a serverless project? I would say no. I love Swift. And what could help you to run a tool, a starting tool? Let's write something just to show you that, we can send emoji, and I submit my post, and here is my record. So at this time, I did an insert on my database, and also I read the record from the database. Let's see if I can update my answer. For example, we have 2 flowers here, update, and then we have we have, for example, another record, just a quick one. And as you can see, it's quite fast. And then I can delete the record. Cool. So all the basics operation that we need to do with an API are covered by the app. So it's basic app. Let's see how is made. My entire app is based on this data model, which is a codable structure, which of course can be encoded and decoded in JSON. And as you can see, it's not so simple, because there is some array, like the field array, and the field contains types that are enum. So it's not just a normal basic struct. Well, it's quite complex. And also I specify one of the codable keys, like the form key. Pay attention, they have also two fields called created at and deleted at and updated at, because they are important for later. So what we do here is that we store this structure in a DynamoDB table. DynamoDB is another serverless database, which is a NoSQL database, which is quite fast, has predictable performance, and is quite scalable, and is fully managed, so you just need to run it. And you can store key value data models. Maybe it's not readable, but that data model is exactly the mapping of the struct in Swift to the DynamoDB code, to the DynamoDB record, which is a little bit of a JSON with some fancy type. So what we do is that the job of translating the codable struct to the Lambda, to the Dynamo, is done by the Lambda. So the Lambda will get the codable struct and will convert it to something in Dynamo. This is the architecture of the app. I guess most of the app we ship have this architecture. So you have the app, you have endpoints, and they are exposed by some API gateway. In this case, is the Amazon one. And then you have an authentication provider, which in our case is signing with Apple. So nothing special. Have you seen the performance are quite acceptable? It's no magic. Behind the scene, this is the serverless architecture that we have. We have 5 endpoints, one for each operation. We have a post, we have a get, we have a put for deleting, for updating, we have the delete, we have a get for listing the items. All of these are exposed by the API gateway. And each of these is mapped to the Lambda that you see on the other side. So, for example, the first is mapped to the first on the right. And the Lambda has the business logic to translate the request and convert the request to do an operation on DynamoDB, which will be specialized by the particular code. I will not spend that much, because I think Sebastian did the job for me of introducing what does the Lambda and these other things. Maybe if you have question later, we will answer. Let's jump now in the code architecture. So the code that I wrote is part of the code is required to connect from the app to the API gateway. And for that, there is a library called the Bridge Lambda API client, which is just Swift code that use foundation to call the API. So I use that because you can pass in that library the structure, so it will be easy for you to create the code. I will show you later. The good thing is that we share the model between the front end and the back end. This is a very cool advantage because if I share the same code structure on the client, on the server, I'm sure it's gonna work. I'm sure that if I pass my UTF code, it's gonna be decoded correctly. And that's not granted by all the languages. I work with other languages. For example, I got a backend in PHP, and we had a lot of problem in converting Unicode characters. On the other side, we have the Lambda, which again gets the struct from the shared model, but it relies on two other services. One is the Breeze Lambda API, which interacts with the Lambda runtime, and one is Breeze DynamoDB service, which interacts with Soto DynamoDB, which is a package that allows you to interact with DynamoDB in Swift. The particular thing of this architecture is that I don't create 5 lambdas. I mean, I create 5 lambdas, but they have the same code. So the code is the same. And what changes is that I tell the lambda, start and be the create, start and be the read, start and be the update. Okay, let's have a look to the code. The client one, as I anticipated, it's a client library which uses sync await, and to be specialized. So this is if you see in the middle, in the init method, Breeze Lambda API client gets a generic parameter which is the structure that we prepared before and is in the shared model. Then we pass the environment, which will tell us which endpoint we need to call, and some other information like the path. And of course, if we enable the authorization, we need to pass the JWT token. So this is something that is written in the demo app, but could be specialized in as you want in your code. So the important thing is that at the moment we don't know the base URL of the endpoint. We will know once we deploy the serverless API. So keep in mind that you need to copy the URL to make it working. So that's the app. The app is open source, so you can download it. It's Swift UI, and just call this service. I will not go in the Swift UI code because I don't think it's part of this thing. And this is now we get to the magic, and the magic is that the Lambda has only one line of code, which is this one, Breeze Lambda API form.main. That's it. And this is possible because Swift is very powerful, because we have generics. We have a lot of constructs that allow to do things that in other language you dream. And for example, if you do this in JavaScript, you need to check that all the types that are arriving from the parameters are really valid. In our case, we get the parameter. If we are able to decode the structure that we get in JSON, we know they are valid. Otherwise, we fail the Lambda. So we don't even need to validate our input. It's for free. It's coming from the language. The only things that you need to do to make it working is to conform the Lambda to the Breeze codable which is a small thing that you need to do to make sure that you can save your form in DynamoDB. One is the key, which is of course the primary key of the table, and the other two fields are required for optimistic locking. Optimistic locking is required because you have multiple clients that can write in the same database at the same time, and potentially they can update the same record. So optimistic locking means that before you can update, you get the latest version of the record. Otherwise, your call will fail. This needs to be managed on the client side, so you cannot you need to manage this because you cannot solve it in another way. And you create your strategy on how to do this depends from the application. So that's the code. It's not that much. Okay, let's go in the discussion of the infrastructure as a code, because here the infrastructure as a code in the backend territory is a religion discussion, because everyone has his own way to deploy the code. Of course, he loves SAM, I like serverless. My colleague in the previous combat loved Terraform, and they don't allow to deploy something if you don't use Terraform. So this is the choice I made. Probably in the future, let's talk later, but could be something that could be supported differently. But what you need to do on the serverless, those YAML is very similar to what you do on SAM, which is describing that you want the APIGateway, the Lambda, the Dynamo, the package, and the IAM, which is like the permission that you give to the resources, and where you store the package. Exactly what Sebastian showed before. Okay, the thing is, in this case, I want to use another approach, which is, if I want to do what Sebastian showed us, I need to know how to write my SAM file or my serverless.yaml, which for us, coming from iOS developments, looks quite hard. So how can we start doing that? And thinking a bit, I got this idea. So rather than knowing what I need to do, rather than know how to do it, I know what I want to achieve. And what I want to achieve in this case is to deploy a REST API with my structure. And I will squeeze up the configuration file in a different way, and I extract only the parameter that I need to run that particular service, which are the service name that will be deployed on AWS, the region, the version of Swift, and then some configuration, for example, cross origins reference of the API, the authorizer. The authorizer in the case I show is just the bundle ID of my app, so nothing fancy. And then how I want to call the code I generate, the target name, the package, the codable. So I have a command line that will generate a full project with the package Swift, with the script YAML, with the built-in script, all in once. And once it's ready, you can decide to modify, inspect, decide what to do. So this is the syntax. You need to download the code from the repository, and then once you run it, let's run it. you will pass the configuration file and the target directory that should be empty. That's the run of the project. You will see that there is a list of files that have been created, and then at the end there is the list of the command that you need to do to complete the deployment. So one is to go in the directory you prepared, and the other one is to run the build script. As Sebastian explained before, we need to deploy on Amazon Linux. So the build script uses the same command that has been shown before, but is prepared because if you need to do yourself that job, you need to remember where is the build, how call the package, where is going to. There are a lot of things that are very small but time consuming to do, and they're already there for us. And then you can deploy. So this is the build. I will try to go a little bit faster because the build builds the Docker image that you need to run, and then I will run the Swift command with download the package, so it will take time. I will go to the end. So this is the completion, which generates the package in a build folder, and that's it. Then we need to deploy. To deploy, in my case, I use serverless framework, and I just need to run this script. Before I run the script, of course, I need to have the AWS credential, I need to install the serverless framework. All these things are very well explained in the serverless website. So you go there, they explain how to set up your permission, how to do all these things. So let's take for granted that you have done it. At this point, you can run the deployment, which will take a while, not that much, because the good things of having one single Lambda is that I deploy the code, I upload the code only once. So the amount of time I spend to deploy the code is very minimal because it's just 17, I don't read very well from here, but it's 37 megabytes, it's not that much. At the end, I will get all the endpoint I've created, and what I need to do now is to copy the endpoint in my API client, and I can run my app. So from the code generation to deployment, 10 minutes. Okay, let's recap the workflow you can use. You need to clone the Bridge framework. You can copy the configuration from the README. Then I suggest to fix the authorizer. Sebastian, I guess if you don't authorize the Lambda, you can have some attack, and your bill could be quite big. Instead, if you have the authorizer, I think is the more guaranteed that you can have less DDoS attacks, or they are managed from AWS, right?
DDoS is managed by AWS, but yeah, someone can figure out the URL and call your URL every second.
Yeah.
I call that a billing attack.
Yeah. Okay, so do that. So don't leave your API open. Then at this point, you can open the. Let's see if I can show you the code. So you can open the. No, let me mirror my display. So you can open the code. We are in the generated folder, and we have here the Swift package, and then we get our sources, and we have a a form that is just a template. So here you go here and you change your structure, you do your code. You can test the code in Xcode to make sure that it builds. Once it builds, you can run the build and deploy with Breeze. So let's go back to the slide. I lost it. Okay. So we build, we deploy, and at this point you can implement your app using the API client. Let's finish with some consideration. Why we should use serverless, why Swift, why Breeze. So the benefit of this architecture is the time to market, in my opinion, and also the opportunity to do your self project, your indie project, and literally paying when you have the case for paying. Because the problem of using Vapor is a very nice tool, which I used before starting doing serverless. But with surprise, I got a £10 bill after a few days, when with this, you don't have it. So the day you scale up, you will of course pay, but in proportion of your business. So if your business is a small app, there are a few users, the cost that you have to maintain something that is always on, it's that much. In addition, I think this is green because you keep your stuff on when you need. When you don't, you stop it. You know, keep things that are running there. There is a point, probably Sebastian could help on that, in which you have so many requests that it's better to transition to an infrastructure which is like EC2 but to get there, I think it passes a lot of time. And most of our apps often, even if we're small in a small department of a company, there are few users. So most of the time the bill is 0 or £20, but for everything. So why Swift? Of course, we are iOS developers, so we love it. And we don't need to learn a new language because at this point, what we need to learn is how to use the AWS services and how to integrate them. And with the Lambda, the only place you put the code in AWS is the Lambda, because the other services are consumed from AWS. So you can call the Lambda using the Soto library, which covers all the services in AWS, and you can run your infrastructure totally in Swift. How to convince the other people? Don't try. So okay, so let's recap why I create Breeze. I worked with Swift for a long time. I realized doing that project it's very powerful because enable a single person to run a business entirely from writing the app to managing the server. And I think it's quite intriguing for us because we always try things, new things, new stuff, and like it. The difficult part is to set up the YAML file, the starting point, is question. And if I do something wrong, if my bill goes up to the sky. So I create this package to start with something that I use for an app that I have on the store. I deployed 2 years ago. since the app is not so successful, but since then I didn't pay a penny. And the day I will pay a penny, probably I'll be rich. So so the idea is having a starting point that you can use, try it, but it's also open, because once the project is generated, you can go back to the YAML file, you can change something, you can tweak something, you can add your other stuff, and that's it. I forgot to mention there is also a remove script in the repo. So once you finish, you run remove, and all the things that you have in the package are destroyed. So no risk to leave something on AWS. It's open source. All those things are open source, including the library I'm using, like the Swift Lambda runtime, the Soto library. So everything can be inspected, modified at any moment in time, and we know as iOS developers how this is important to have open things. And it's on GitHub. If you want to have a look. If you want to get involved. It could be interesting because let's go back to why I do these things while I'm doing iOS. Because I learn a lot of things about the language mostly. Because you have a language that, in opposition of what happened to WWDC, that you see fancy things, you dream to put these things in your app tomorrow, and then there is a sad reality, which is that you work for a business that cannot be disrupted, and you can put them probably in 2 years. The good news with server-side Swift is that once we have a Docker image with the language, latest version of the language, we can have and we can deploy a serverless or something else the day after. We stick to that build until we like it, and the day we want to change it, we change it, because nobody forces you to upgrade. This library, as you see from the badges, is 97% fully tested, including the operations that are made on DynamoDB, because I used a spin up in the pipeline, local stack, which is Docker image that mimic what AWS does. And it is also interesting to learn other things like GitHub Action, how to deploy something on GitHub, how to get the code coverage of your packet. So that's why I'm quite intrigued in that, not just because I do my app with serverless, but also because for my daily job, I learn a lot of things about the language. Okay, thank you.